Algebra 2. Hey, today's first video is about how to find the exact trig values, particularly if you have a reference angle of 30, 45, or 60. For example, let's just start with one pretty basic example. Let's determine what the sine of 45 is. So what we're going to do is we are going to find out like where 45 is on this coordinate plane, 0, 90, 180, so 45 is right in the middle. We know this by now. 45-degree angle right there. And what is the sine of 45? So sine of 45, we remember that cosine is our x value, sine is our y value on the unit circle, pretty much just because our hypotenuse is 1. So according to this reference angle down here, our x value is adjacent and our y value is opposite, which corresponds with what you learned in geometry with SOHCAHTOA. That's our opposite side. So when it asks for the sine of 45, it's really asking for the y value of that point at 45 degrees. So it's like, what would you put there? And then it's the y value. So I don't care about x right now, I just care about y. And we're going to be using our special right triangles for that. Here are the three specials we use, the 30, the 45, and the 60. So if we have a 45-degree angle, we are going to use our 45-degree special right triangle. And we know that the y value at that point on our coordinate plane, our y value is square root of 2 over 2. And I got that value from right here. It's just like we put this on a coordinate plane, and we want to know what that point is, so that would be our y value. So the sine of 45 is the square root of 2 over 2. Our first example here, cosine of 120. If this is 0, 90, 180, we got to figure out where 120 is. So I'm going to go past 90 a little bit, but not really close to 180. So that's going to be up here. And if we're looking for this angle down in here, that's not quite 180. So 180 minus 120, that's going to be our 60-degree angle in there. So the question is cosine. So cosine is x. So we're basically asking for the x value of that 60-degree angle. And if we think about our special right triangle, if this is a 60, the bottom is a half, the top, or the long side is square root of 3 over 2, so the cosine should be 1/2. Now before you get too excited about that, think about our coordinate plane, and if we go back, this should be a negative x value, because x's are positive, x's over here. If we go back, they're negative. So the cosine of 120 is actually negative 1/2. So a couple things to think about here. Set your angle. Where's it going to be on your coordinate plane? What's your reference angle? And then after that, figuring out, like, you want your x value or your y value. Is it positive or is it negative? A lot of things to think about. And that just erased, so if you just rewind a little bit, you can see it again. Sorry about that. So I just found out I can just move my graph over then if it all disappears. But go ahead and figure out sine of 330 on your own. Pause the video. This is always a great opportunity for you to kind of challenge yourself. Do you get it yet? Do you want to listen to one more yet? That's up to you. Do what's best for you. 330 degrees is almost a full circle. And to figure out how much is left, I didn't go a full circle. I only went 330. So I'm left with a 30-degree angle. So I went almost all the way there. Oh, and then I guess I already found the reference angle. Silly me, I was going to kind of leave that for you. But this is a 30-degree reference angle because that's what takes us from our line, our polar angle, back to the full circle. So sine is y. We know that cosine is x, sine is y. So we are particularly interested about our y value here. Looking at our special right triangle, the measure that's opposite the 30-degree angle would be 1/2. And again, like the last one, we are going down, so those are negative y's. If you go up, those are positive y's. So down is going to be -1/2. Hopefully if you tried it on your own, that's what you got. I'm going to put a couple more problems on the next page for you to look at, practice on your own, and then I will give you the answers to them.
So,
Here are the 3 for you to practice. If you could go ahead and work on these 3. Do yourself a favor and actually pause the video so you can work on these on your own. Whoop, whoop. Okay, here comes the answers. Here come the answers. First one, here's the 240-degree angle, which gives us a 60-degree reference angle to work with. And since it says cosine, we are going to be looking at the x-axis. And we know, based on our special right triangle, that the short side is 1/2, the long side is √3/2. So our x value is going to be 1/2. Because we're going backwards, it's -1/2. Next one. Again, drawing -180, negative, you go backwards around that circle. 150 degrees from the 180 leaves us with a 30-degree reference angle. If we kind of sketch that out, the 30 is the little one, and across from that would be 1/2. The top would be √3/2, so we're going down 1/2, also known as -1/2. Last one, tangent. Whoop, whoop. Tangent, if you remember correctly, it's not just like cosine and sine is y. Tangent is opposite over adjacent, so it's kind of like we're going to take the sine over the cosine. It's kind of funny, but it works out the same. So opposite is √2/2 over adjacent is √2/2. And this one's a little bit easier. We know anything over itself is 1. To prove it to you, though, remember whenever you're dividing by a fraction, you can multiply by the reciprocal. You can flip it upside down and multiply, and that helps us because you have 2/2 and you have square root of 2/2. So it cancels to 1 whole. Green on green, not a great idea. 1 whole. Okay, so that was today's lecture. I'm going to go to the next screen and just post a couple more questions for you to look through. Okay, go ahead and just pause the video on this screen right now, and here in a couple seconds the answers will be there. Pause the video, please. And there you go. Go ahead and look through these answers. Here's kind of the solution to the first one, the second one, the third one, and the last one. And let me know if you have any questions. Thanks, Algebra 2.